we want to be able to find a confidence interval for the population mean of an item. All right, we all want to find now, for this problem, we're going to find the population mean for the cost of sleeping bags. And we get a random sample of prices for the sleeping bags. And we want to be able to find the mu. The first thing we want to find is how many items do we have in our sample, how many pieces of data. We click equal count. We're going to go scroll down all our data, and that is going to tell us that we have 20 pieces of information in our sample. For the X bar, remember X bar is the average, so we type in AV, we click on the average, and again we want the average now of these 20 pieces of information. So we scroll down over here, we get the 20 pieces of information, and we see the sample average is $89.60. For the sample standard deviation, I'm going to go to my formulas. I'm going to go to more formulas. I want the standard deviation for the sample, which means we want STDEV.S because that gives us the sample standard deviation. We want the numbers again. We're going to click on, and I'm going to start from the bottom to make sure I include all of them. I don't want the cost in there, so it's from 80 to 70. And I get the standard deviation is approximately $19.95. Now that we have the basic information, we're able to create our 90% confidence interval. The alpha is 1 minus the 90%, which is going to be divided between the left tail and the right tail. In order to get the margin of error, we're going to go to our formulas for confidence.t. So we go to more functions, statistical. We go to confidence. Now confidence.norm is if we have the population standard deviation. Getting the sample standard deviation, we use confidence.t. We have our alpha, which is the total area on the left tail and the right tail. We're taking the standard deviation of our sample. We're taking our sample size, which is 20, so it's going to calculate the S of X bar. And that tells us that our margin of error is $7.71, which tells us that the population mean could be $70 and $7.71 less than the $89.60 or larger than the $89.60. So to get those boundaries, we go to the lower boundary where I'm going to take the $89.60, subtract the $7.71, and that tells us that the sleeping bag, the average, could be as low as $81.89. Alternatively, the largest price, or the most expensive mean, would be $89.60 plus the $7.71, which tells us that we say we are 90% confident that the population mean is anywhere between the $81.89 and the $97.31. So that tells us the range of numbers. Now I'm going to show you a much faster way of getting it. For those of you who have PCs, you can go to data. You can install data analysis and figure out how to do that. If you have a Mac, you should be able to do that also. If your Mac doesn't allow you through tools to include the data analysis package, you can do that on Google Sheets. So I'm going to go to data analysis. I'm using the descriptive statistic tool because you have many different analysis tools. I press OK, and I've used this before, so I want to make sure that all the data is missing or not here. I'm going to start from scratch. All right, so the first thing we want is the input range, and I'm not going to include the cost. If I were included the cost in there, I would have put labels in the first row, but I didn't put that there. Now I have the output range because I want it on this worksheet, and I'm just going to click one cell. That's all we need to do. Please make sure to click on Summary Statistics so you get all the information about the data. You're going to put in the confidence level. We are looking for a 90% confidence interval. If you want 95%, you just change it to 95%. If you want 99%, you can change it to 99% here. We click OK. All right, let's go back here. I forgot. Oh, and my input range is missing. I thought I scrolled it in. Okay, now I have everything I need. Notice the computer is very smart, tells us what we're missing. So now all the information is there. We press OK. I'm going to make this a little bit larger so that you can see it. And what do we notice? Well, we have the mean is the same. The standard error is not the error confidence, the error of estimate. It is the sigma of the x bar. It tells us that what the sum is. It gives us the count. But notice, and this is the number that's important, it gives us exactly the same value that we had from confidence.t, which means that the mu is still on this interval. Now, let's say we take a look at it and we say $7.71 is too large of a margin of error. I really want something smaller. I want the population mean to be within $5.50 of the $89.60. I want it to be a little bit tighter. Well, I'm going to take the alpha, which is our 10%. I divide it in half. And when you divide it in half, you get the area on the right tail. But I want to get the z-score from the left tail so I don't have to subtract it from 100%. Using the left tail area, I'm going to go to norm.s.inv. So I go to my functions, and I go to norm.s.inv. So I can put the area in on the left tail, and the probability is a negative 5/10. And that tells me that I should be getting a number. It doesn't like it. So I'm going to do it the other way. I'm going to say that this is equal to 1 minus, and I'm going to go back to that formula to norm.s.iv. I'm going to put in the 5%, and this is going to give us, oh, that's interesting. Let's see what happens. Let's try that. Now, all right, that gives us the 1.65. I guess you didn't have to do that. Once I put in the negative, it automatically gave it to us. All right, now we want to find the n. Now remember, the n is going to be equal to the z-score times the standard deviation, which is the $19.94, divided by the margin of error. I'm going to take this entire formula and I'm going to square the results, all right? Because we take the square of that, all right? So we raise it to the second power, and that gives us 35 point anything. Now, because it's more than 35 and we cannot take a portion of that, we're going to say that our sample size has to be 36. So if we added 16 more, all right, samples to the 20 that we had, then we would find a margin of error based upon that sample mean of $5.50. Okay, enjoy.